increase the delta, that small triangle. In mathematics, we often use it to represent changes. So that means you want the value at each step. So let's see point 1. That means increase by 0.1. So I want to see what is the function, how the function behaves. So table, here it is. I start from 1.2 is 3.5, 3.6, 3.9. Then error at 2. Why? Because at 2 your function is not what? Not defined. So that's why it's an error. Now I can change this. I change the step by 0.01. That means I make the step smaller. So that means I get more value. So when I do the table, you can see I still get 3.5, 3.56, 3. And this x increase to 2. The value gets bigger and bigger, but seems always less than 4, right? We are bigger, closer to what?
4.
Error. Then let's look at the other side. Bigger than 2 side. Can you see it's bigger than 4? But as x gets closer to 2, what happens? It gets closer to 4, seems. Get closer to 4, right? So actually what we notice, I'm not going to complete this table, you already have it on the calculator. Of course you can use smaller delta value to get more values. This is our initial study. We realize as x gets close to 2, but not 2. Why? X cannot be 2 period, right? So fx gets close to what? 4. And in this case, we say if this is true, I'm only going through this and realize that. Assume this is true, that in this case we see the limit of fx at x goes to 2. Is 4. Yes. Alright, the limit of fx at x goes to 2. The limit value is 4. Where your function value close to is the limit value. The x close to something is where your variable is. So actually we are having 2 processes here. One process x is getting close to what? 2. The other process correspondingly on the y-axis, there is y is approaching to what? 4. So what's the notation here? We use limit L. Then we write here x goes to 2. That's the process, that's where your x goes to. F of x equal to the value 4. The limit of fx as x goes to 2 equal to 4. Alright, now let's look at the picture. Actually, you can easily graph this function on your calculator. If you graph it, you will realize it's a straight line, actually. Everybody, let's just change this. I want to check the window. That's fine. I think the window is not that straight. So I'm going to graph the function. What do you think? It's a straight line. Is it really?
No.
What happened?
There's a little circle missing at the point.
There is a circle missing. Actually, circle missing over what value of x? Over 2, right? Because at 2, your function is what? Undefined. So, what we see the picture is, actually, let me rewrite this. Fx equal to x squared minus 4. I need to do out. That equal to x plus 2, x minus 2, x minus 2. Correct? Now you see what can I do?
Cancel them out.
For any x?
X minus 2.
Cancel x minus 2. Can I do that?
Yes.
No. Well, you can, but it's not the full. It's not the full like equation.
You can do that if x not 2. If x equals 2, the top is 0, the bottom is 0. You can cancel 0 to get 1. You cannot. Alright? You can cancel the 0, get the fraction to be something. You can't. When you have a fraction, if the top has a factor, the bottom has a factor, you can cancel the factor as long as that factor is not 0. Alright? If it's 0, top is 0, bottom is 0, it's undefined. You can cancel it, make it defined, you can do that. So that's this. Undefined if x equals 2. Alright? Now, not surprising, we see a straight line here. Negative 2 is 0, positive 2 is 2, x. Very easy to graph the straight line, right? At 2, there is a circle undefined, so your graph looks like this. Actually, the calculator cheated you. You didn't show you the whole, but don't blame the calculator. You need to realize it. Now, everybody, can you see here the two processes? I really emphasize this, even the example is simple. But if you understand it here, your life will be easier. Next class. The x is moving on the x-axis. That's what x is going to. X moving toward 2. That's one process of limit. The other process of limit is right here. That's a 4 corresponding to that circle. Alright? Your y for each x, this is your fx. Try to imagine, everybody, try to see a movie in your mind. X is moving close to 2 from the right side. And your fx correspondingly going to move down from bigger than 4, moving down toward 1. The point 4. Can you see the two processes here? Right? Now, the next process it would be, if your x is here, then your fx will be here, right? Fx will be moving up as your x moving up to 2. Correct? But in any case, your x cannot be 2. But the function, the behavior, I know it completely. What happened? If your x move closer to 2, fx moving closer to 4 on the y-axis. Correct? I draw this picture purely for your understanding here. We cannot do this for every function. So you need to see the process to generalize it. Okay, this is one example. Everybody, is that clear? Any questions? Are we good? So let's move on to another example here. I call it gx this time. X squared minus 4, x minus 2, all right? Absolute value. Absolute value. Then I'm going to consider this function here, all right? I can do the same thing, on my calculator to have a table. All right? But I could also graph it, certainly. Correct? But let me take a different approach. I'm going to simplify this first. Then we can clearly draw the graph, then you can do the table value just like what I did for the last function. All right? So let's simplify this. This can be factored as x plus 2, x minus 2, divided by x minus 2, that's absolute value. Can I cancel the x minus 2? No. It depends on your x is positive or negative, right? Remember the absolute value formula? I keep emphasizing. We only need the second time. Last time I did, today I did. Right? So here we really need to consider your x bigger than 2 or what? Less than 2. So here it is. This is x plus 2, x minus 2 divided by x minus 2. if x is bigger than 2. Am I right? Because the absolute value of x minus 2 is x minus 2 if x bigger than 2. Everybody, is that clear? And in this case, can I cancel it? X bigger than 2, x minus 2 is not 0, I can cancel it, I get x plus 2. Now, x plus 2, x minus 2, negative x minus 2, if x less than 2. We said x is not defined. The function is not defined at 2, which I didn't mention, but clearly everybody from last example, you know that x do not equal to 2, right? Again, I'm interested in what happened when x is close to 2. This, can you see I can cancel this? What do I get? Negative x plus 2. Yes? Can I plot this function then? Yes, I don't need a calculator to do that. X plus 2, we already did it before. That's 2, that's 2. Right there. X plus 2, x bigger than 2, the function is part of the straight line we plotted last time. So it will keep going like this. Correct? But on this side, yes, there's a straight line, but it's not part of my graph. Because x bigger than 2 is defined by this. Are we good? Now, if x less than 2, it will be a straight line again, but this time the slope is negative. And let me just plot this straight line, all right? X is negative 2, that's 0, so go through this point. If x is 0, that would be negative 2, so right here, correct? So I can plot this straight line. I hope I can do it. Of course, the straight line keep going, but x bigger than 2, our function is not defined by this. So everybody is not exactly straight that. You know I'm job plotting straight, right? All right. That's the graph. Now, I hope you can see, based on what I told you last time, I hope you can see clearly the two processes going like this. If x going like this, fx, this is 4. fx goes to 4. Correct? But if x goes to, let me use a different color, if x goes to this way, that's fx. fx will be moving toward what? What is this point?
-4.
Negative 4. Correct? In this case, as x approaches to 2 from one side, it approaches to a number. F approaches to 2 from the other side, it approaches to a different number. All right? So what we notice, as x goes to 2 from the right side of 2, from the right, fx goes to what? 4. And also, as x goes to 2 from the left, fx goes to what?
-4.
Negative 4. Correct? In this case, we see the limit doesn't exist, but we do see, because of this, we would see the right hand limit, or the limit from the right is 4. Notation is limit x goes to 2 plus. What does 2 plus mean? Goes to 2 from the right. 2 plus a little bit. fx is 4. That's the notation. And the limit x goes to 2 minus fx equal to negative 4. Okay? 2 minus. Minus means from the left. I'll make this official next time. But if you want to look at some problem, I can give you a few. I really didn't finish the whole section yet, but we are getting close. So look at page 75. You can look at 3, 5, 7, 9, 11, 13, 15, 21.